Right. So up to now we have discussed about the resting membrane potential. Now we will discuss the action potential. Before really going into detail about the action potential, I would like to tell the what is action potential. Action potential is simply the potential which is in action on the cell membrane. It is working on the cell membrane. First of all, we have discussed the resting membrane potential. We will take the review right now, but we will discuss the how the resting membrane potential convert into the action potential and how this action potential is propagated, which is ultimately called nerve impulse. So let's take the review faster. This is the sodium potassium pump which throws sodium out and potassium in using the ATP. You know, this is the electrogenic pump. Using the ATP throws 3 sodium out, 2 potassium in, bringing the cell membrane more electronegative. It's about minus 5 millivolt. And then potassium inside its concentration is high, it always tend to move outside, but electrical gradient on the potassium act inward, that is very little. And you know, at the resting states, cell membrane is always permeable to potassium, but impermeable, like sodium channels are closed. These channels are closed, but the potassium channels are open, potassium leaky channels, remember. So this potassium constantly moving out, bringing the cell membrane more electronegative, minus 5 to minus 10, minus 60, somehow minus 90. And the state will reach that the net movement of the potassium will stop because the electrical concentration gradient is exactly equal to the electrical gradient, and the resultant force will become 0. So we can say the potassium achieved, or cell membrane achieved, the equilibrium potential for the potassium, which is almost minus 70 to minus 90 depending on the cell type, and RMP, resting membrane potential, is always near to the equilibrium potential for the potassium. So this is what we have discussed in the previous lecture. Now we have to, this is the resting state, this is the resting cell. We have to convert this cell into the action potential. How? Like just suppose this is the neuronal cell. Now just suppose this is the neuronal cell, nerve cell, and this is at resting. Resting means if there is no stimulus approaching the cell. Stimulus can be external or internal, but just suppose this is the neuronal cell and this at resting state. Now what happens? Let me draw another cell. Just this is the neuronal cell at resting. Now if just suppose this is the, okay, let me tell you, fine. This is, you know, spinal cord, and from here, you know, there is a neuron. Just suppose this is one sensory neuron ending at my finger tips. Now this could be the dendroid or axon. This could be the dendroid, because dendrons and soma, yani ke body, cell body, is responsible to taking the information, and axon is transmitting the information away from the cell body. Now just suppose this is the nerve ending at my fingertips. Previously it is at resting state, this state, sodium out, potassium in, and almost it was about at minus 90 millivolt. This is the RMP, this is the RMP. Now by any mean, if I stimulate this nerve membrane, this is the membrane of the nerve cell, if I stimulate, or mechanically or chemically, whatever the mean, if I stimulate, what does it mean? Remember, these are the previous situation, potassium channels are always open, even though during the RMP and during the action potential. Another channels, these are the sodium mechanical channels. Remember, these are the sodium cation mechanical channels. Actually, these are the cation, or probably the sodium, because sodium is also the cation. Mechanical, don't confuse it, the voltage gated channels, those know the action potential. Cationic mechanical channels, whatever the means. If I trickling this membrane, and the little sodium come inside, little sodium, because sodium is the cation. I will show the sodium like positive. If I touch the membrane or by any mean we stimulate the membrane, a little amount of sodium will comes out, trickling inside. What will do this? What will this sodium will do? This sodium will bring the resting membrane potential, which was previously minus 90 millivolt. It will try to neutralize it, because these are the positive charges, and if the room is full of the negative charge and I open the positive gate, and positive charges will come inside, the negative charge will disappear. And the same case, if the sodium will come in or the positive ion will come in, it try to lose this electronegativity, it try to depolarize it. Just suppose here this was almost minus 75. I will tell what is this. This is the threshold value. Actually, threshold value, what is the threshold value? Threshold value is the minimum requirement or the maximum requirement to achieve the action potential. And just suppose these sodium come inside and it will bring the it will depolarize or neutralize the minus 90, try to depolarize, but these positive ions are not enough and this will die. Why this will die? Actually, whatever the amount will come in, the potassium loses out. So, there is a no net electronegativity loss. So, only then if we bring the stimulus, enough stimulus, a powerful stimulus that bring the cations in, that are enough to bring the resting membrane potential up to the threshold, then at this particular time, this is a threshold value. This is, in my example, this is minus 75, but it also varies from cell to cell. In this cell, this is the threshold value is minus 75 millivolt and minus 90 millivolt is the resting membrane potential. If I stimulate the cell membrane and the sodium ions come inside and making the depolarization of this membrane, or you can say neutralizes the membrane, or you can say become less negative to this minus 90, it will taking this resting membrane up to the, you can say, minus 90 to minus 88, then minus 85, then minus 80, then minus 75, and up to reaches the threshold value. When it will reaches the threshold value, first the previous this will die. From the threshold value between the RMP, the potential is known as sub-threshold value. The potential between the RMP and the threshold value is called sub-threshold value. Here sub-threshold potential. Sub-threshold potential. Remember, at the sub-threshold potential there is no action potential. Still, this, if the sodium positive ion come, not enough, that it will dies out. Even again the sodium ions come, it will bring the minus 90 to minus 80, but not touches the threshold value, it will die. So, these are the not action potential. What are these? These are the local potential. These are the local potential. I am not going in detail about the local potential because this is not the concern with the FSC. Now, come to the point. I stimulate the nerve membrane and the little sodium ions come in. Again and again, I stimulate the nerve membrane and the positive ions come in. That the situation comes that the positive ions which are coming inside is more than the positive ion losing outside. Then at only these circumstances, it will take the RMP up to the threshold value. When the threshold value achieved, what will happen? A very important event occurs. There is a sodium gated channels present inside the cell membrane. Initially, when we discussed the resting membrane potential, the sodium gated channels, sodium voltage gated channels, these are the sodium voltage gated channels. These were shut off in the RMP, but now actually I will tell that this sodium pump sodium channel in little detail. This is the sodium channel. It has two gates. One gate is like this and one gate is like this. Listen, this is the activation gate. This is the activation gate and this is the inactivation gate. This configuration. Whenever you see the sodium channel like this is closed. This is the closed channel. Even though inactivation gate is open, but activation gate is closed. This is the closed sodium channel and this is at resting state. This is at resting state. So, before stimulus, the sodium channel is like this. But when I say that I stimulate the nerve membrane enough that it will success to take the RMP up to the threshold value, then what events happen? These sodium channels will rush open and the activation gate opens so fast and the inactivation gate also starts to close, but its activity is slow. So, during the active state, the sodium channels look like this.